morning, ladies and gentlemen. My name is David Mekie from the Tool Connection. Some of you might know it better as Laser Tools. We have our stand right behind us here, so some of the things that I'm going to show on the screen here, you'll be welcome to come and look at afterwards over there. So this talk this morning is on the subject of high voltage batteries and the market opportunity created by high voltage batteries, and more specifically, how do we actually get high voltage batteries out of vehicles and get them back in again. So this is a schematic of a typical battery electric car, and what you can see on the screen there is that the vehicle has a very large, what we call a traction battery in the base of the vehicle, and the battery effectively forms the floor pan of the vehicle, and that's a very common structure for battery electric vehicles. Noticeable point on a vehicle like this is it still has a cooling system which is mounted at the front here, very similar to the cooling system you would find on an internal combustion engine vehicle. Many of these batteries are liquid cooled, something we need to remember when we're going to take the battery out. So, the market size for battery electric cars. This gives you the statistics taken from the SMMT of battery electric car sales this year so far. So this year so far, battery electric vehicles, 77,000 up to the end of April. And what's interesting is 14% market share of battery electric vehicles on their own. 14% market share, plug-in hybrids another 7%, and traditional hybrids another 12%. That means high voltage vehicles collectively is about a third of the market already. And you can see, compared with previous years, plug-in hybrids are kind of static because battery electric are taking over. You can see the market share. The overall market though, as you can see at the bottom, the overall car market is down 5%. And at the very top you'll see why. Diesel has completely collapsed. Diesel is going backwards at a significant rate. Historically, this is the sales. So what's interesting here, battery electric vehicles on the top row, 4 or 5 years ago, we were only selling 13, 14, 15,000 a year. The big change happened in 2020, leap up to 100,000 battery electric cars. Last year, very nearly 200,000 battery electric cars. This year already, projections are anywhere between 250,000 and 300,000 battery electric cars on their own. Round about here, plug-in hybrids were always outselling battery electric, but from 2 years ago, all of a sudden, battery electric takes over from plug-in hybrid. So the market is moving more towards battery electric now than plug-in hybrid. What's also interesting on this is if you look at all the high voltage vehicles collectively, this line tells you how many each year, and you look at the bottom, and let's go back 3 years ago to 2019, 700,000 high voltage vehicles will now be 3 years old, which means that's an additional 700,000 vehicles requiring MOT, but they're high voltage vehicles requiring MOT. Roughly speaking, there's 23,000 MOT stations, so if you divide one into the other, that's about 30 vehicles per station per year. So many of you will be MOT stations. If you haven't yet started to see high voltage vehicles, you might want to think, maybe I should be looking for that, because they're going to go somewhere, and there's no need for them to go back to the main dealer. Independent MOT stations can deal with these cars just as well as anybody else, but it may make you want to think about getting training if you haven't already had training on high voltage vehicles. Last year, the best sellers, probably no surprise, Tesla Model 3 was the best seller in the market. You see them everywhere nowadays, and you can see the top 10 battery electrics, and you can see also the top 10 plug-in hybrids. And this exemplifies what I said, that battery electric is now outselling plug-in hybrid roughly about 2 to 1. So plug-in hybrid sales level is roughly static. Battery electric is moving ahead at a great rate. What's also interesting on the on the bestsellers is some of these were brand new, only launched last year. Straight in at number 3, Volkswagen ID.3. At 5, Audi e-tron. Brand new cars leaping straight into the top 10 list. Okay. Now this is just to give you an idea of the range of battery electric cars that are currently on sale in the UK. And there's so many, this is actually split over 2 slides. So we've got the first half, A to M here. And this was a slide I put together back in January. And to give you an indication of the rate of change, this is changing quite rapidly already. So for example, on the right-hand side where I've got, for example, Genesis, that model is now available. You can order that. Mercedes, EQB and EQA, they're now available. You can order those. You might also see 1 or 2 brands you might not have heard of. So for example, Fisker Ocean is an American SUV coming to the UK later this year and expected to do very well because its target price is £35,000. Also on here you have Lucid. The Lucid Air is another American vehicle, very similar to the Tesla Model S, but even more expensive. So that's very much a top-end market vehicle. This is interesting. Great Wall is a Chinese manufacturer. The Aura Cat, which is, they've just announced, believe it or not, is going to be called Funky Cat. That will be in the UK later this year. And that's a Chinese brand of pure electric vehicle. And on the rest of the alphabet, so we can see here, the Nissan Ariya is already available. The Polestar Model 3, that'll be an SUV coming out in the autumn. The Porsche Macan EV is coming out very soon. Rivian is an American brand. That's an SUV and a pickup truck, round about £55,000–60,000. What else have we got on here? VW ID.5 is already available, and I just saw on the television at the weekend for the first time an advertisement for the ID Buzz, which is like the old VW camper van, same type of thing but pure electric. So, wide range of battery electric cars now available on the marketplace. So let's just have a little look at some examples of batteries if you're not familiar with these. This first slide shows a couple of plug-in hybrid models. The one on the left is a Mitsubishi PHEV, the one on the right a BMW 3 Series. Plug-in hybrids are always a compromise because they're developed from internal combustion engine vehicles. So you have to find a way to squeeze a battery into an existing vehicle. Hence, they're a compromise. So in the case of the Mitsubishi, the battery is in what otherwise would be the transmission tunnel. Very common with plug-in hybrids, the battery goes in the boot and reduces the space in the boot. They're compromise. When we go to pure electric vehicles, the battery now becomes an integral part of the structure of the vehicle. And I've broken these types of vehicles into 4 different categories for a particular reason. So this is clearly at the small end of the scale, BMW i3 and Nissan Leaf. Batteries are round about the 40 kilowatt level, so you're looking at up to about 200 miles of range maximum, and round about 350, 360 volts, and the batteries are under the floor because that's the way they're going to come out. When we start to go up the scale though, we start to introduce what the trade sometimes calls skateboard batteries. For obvious reasons, they're big, flat batteries which form an integral part of the vehicle structure. So we have the Hyundai battery there, and in fact we have a Hyundai battery on our stand. If anybody wants to have a look at one later on, that same battery is on our stand behind us. That's the Tesla Model 3, that's the single motor version of the Tesla Model 3. And at this point, I'd like to introduce the subject of training, because once you start to get involved with batteries like this, you really need to have had high voltage training, preferably to what's known as level 3. If you haven't looked into training, there are 4 levels, 1, 2, 3, 4. Level 3 is the training level you need for doing work around the vehicle but not specifically in the high voltage system. Level 4, which I'll mention later, is when you're going to work on the high voltage system. So these are typical mid-range vehicles with skateboard batteries. And then higher up the range, we have some slightly more prestigious vehicles, Jaguar I-Pace and the Audi e-tron. And we now go up to sort of 90, 95 kilowatts, 400 volt batteries. Now what's interesting about these batteries is these cutaway sections allow you to see inside the battery. And you can see the battery layout and you can see the individual modules in the battery. And that's because these batteries are designed to be serviced and repaired. Okay? So we're not talking, if you have a battery fault with these vehicles, it's not a replacement battery, it's a service and repair task. But you have to have IMI level 4 training for that, because you're going to go into a live 400 volt environment. And that's not a safe place to be unless you've been trained appropriately. I'm quite familiar with this battery because we did some development work with Jaguar when this battery was being developed. There's a very well written procedure that tells you how to disconnect the individual bus bars and reduce the voltage down and down and down and down until you get to a point where you can take an individual module out, put a new one in, build the battery back up, put the top back on. Batteries are now designed to be serviced and repaired. And referring back to the Hyundai battery that we have on our stand, we have some test equipment there that is designed to help you when you're putting the battery back together, okay, to make sure you've done everything correctly. But up to this point, all these batteries are sort of 350 to 400 volt, and what we're now getting is 800 volt. And in fact, there are now vehicles on the market which use 800 volt systems. The new Hyundai Ioniq 5, which is a very popular vehicle already, and the Porsche Taycan, okay, very expensive, but nonetheless, these cars are using 800 volt systems, and I've already heard of a new model coming out from America in the not too distant future, which is 900 volts. The purpose of upping the voltage is because the public want the car to charge faster. So you need a higher voltage, a battery capable of taking a higher voltage so you can charge at a higher rate. But you have to be able to charge very fast, ultra-fast charging, 270 kilowatt chargers or higher. And the only chargers in the UK that will do that are what's called the Ionity network. They have 350 kilowatt chargers, specifically for vehicles that need 800 volts. You can charge those sorts of cars in 20 minutes, full charge in 20 minutes. So that's why the industry has gone to 800 volts. Now, all these different batteries, when we're going to think about the subject of removing a battery, what's critical is the weight. So we have a little chart here that gives us an idea of the weight of many of these batteries. And as you expect, smaller vehicles with smaller batteries, around the 250 kilos, that's a quarter of a ton. Mid-range vehicles, such as the Hyundai, for example, or the Tesla Model 3, close to half a ton, 450 kilos, getting close to half a ton. And at the top end, Mercedes and the Audi e-tron, 700 kilos, very heavy batteries. We don't believe that batteries will get much heavier because technology now is all about what's the efficiency of the battery. So you sometimes read in the press about a battery, a vehicle and its range, but what's the usable range as opposed to the theoretical range? Well, this is to do with the efficiency of the battery. So at one end of the scale, we've got batteries that are only perhaps 80 to 90% efficient, but at the other end of the scale, we've got batteries now coming in that are 94, 95, 96%. So the industry is now trying very hard to improve the efficiency of these batteries and have a higher density of energy available from these batteries and lighter weight materials. So we doubt that batteries will go beyond the 700 kilos. So we're going to start looking at some batteries and then we'll wonder about how we're going to get them out. This is a Nissan Leaf battery, and this shows you how the battery is fitted into the vehicle. And the battery has a row of fasteners down each side, which hold it into the vehicle, and one or two across each end. Okay? Straightforward fasteners that screw into the chassis of the vehicle, hold the battery in place. You can also see there the high voltage connection points. So with any of these vehicles, before we're going to take the battery out, we absolutely have to go through what's known as the shutdown procedure. And the shutdown procedure involves, at some point, disconnecting the high voltage cables. Shutdown procedures for all electric cars are readily available from most data providers, people like Autodata. They're also available publicly on the internet because they have to be for safety reasons. So all the safety organizations can get access to that information as well. So the shutdown procedure is easily available. Note that in this case, this particular technician is wearing PPE, appropriate to high voltage, because at this point, he's disconnecting high voltage cables. Once those high voltage cables are disconnected, he no longer needs to wear the PPE because the battery, the outer casing of the battery, is not in any sense live at all. So this is, once he's disconnected, he can now start to remove the fasteners. This part's already disconnected. Here's another example. This is a Hyundai Kona battery. This image was actually taken in the factory where they're built. But again, you can see the fasteners are in a line down the edge of the battery, and there'll be one or two across each end. Tesla Model 3, you see the same. Fasteners down the side. In the case of the Tesla, they put a nice piece of trim across it, so you have to remove that piece of trim to get access to the fasteners. I think there's 8 down there, and I think there's 6 either end. You can see them there. Now here's the Jaguar I-Pace. Now this one, the battery's already out. You can see the holes in the battery edge where the battery's fitted. So you'll note the commonality. All the batteries are essentially fitted the same way. Fasteners down each side and a small number at either end. So when we're going to think about taking these out, what we always recommend is you, as we saw in the previous slide, disconnect the high voltage system. You go through the shutdown procedure, disconnect everything, and you can start to remove some fasteners whilst the vehicle is up here. So you can take out the ends, and you can take out 1 or 2 from each side, depending on how many there are. The vehicle's not going anywhere. It's quite safe up on a ramp. Now you'll also notice on this slide, this battery is on a trolley, and then this battery is being lifted by a lifting system. That one happens to be heavy-duty webbing straps. Now that's actually Jaguar Land Rover's official OE equipment being used by this particular workshop. That's the Jaguar Land Rover system, a battery with some brackets that hold the battery and a set of lifting slings. Now that's quite interesting when we come to think about, well, what type of equipment do we actually need? Now, some vehicle manufacturers, and I stress some, not all, will tell you you need a hydraulic lifting platform. So these are examples of a hydraulic lifting platform. This one is the VAG approved hydraulic lifting platform, which costs £7,500 in the UK. This one is for the North American market for General Motors, supplied by Bosch to the General Motors network in North America, and it's around $6,000 in the States, so that would be about £4,500 here. But I stress it's only some vehicle manufacturers that recommend that principle. Tesla, for example, don't. Tesla recommend a bench. This is the Tesla OE equipment, a bench and some lifting slings. Now you'll notice on this bench it has adjustable legs. That's so that you can tilt the bench. You can vary the angle of the surface of the bench. And I'll explain the reason for that in just a moment. But when you're using a bench like that, you've still got to have something that lifts the vehicle up and down, so you've all got a 2-post lift. So you don't really absolutely have to have a hydraulic platform because you've got a 2-post lift anyway. This is the Jaguar Land Rover equipment. So as we saw in the slide on the workshop, a trolley with some brackets. The reason it's designed that way is at some point Jaguar Land Rover will come out with another model that's pure electric, so you simply buy another pair of brackets to go on the same trolley. And a set of lifting slings that will then lift the battery off that trolley. Ford have a similar principle with regard to lifting the battery, some chains and slings, but Ford are quite relaxed about how you get the battery out of the vehicle. They don't mind if you use a hydraulic platform or a bench. Take your pick, really. What we do at Laser, we've developed our own system, and as well as trying to make equipment efficient, we want to try and make it cost effective for, particularly for the independent market. Our view is that if you've already got a two-post lift, which I'm guessing everybody does, why do you need an additional lifting device? You've already got a lifting device. So we use a bench. This is our bench, and we have adjustable legs so that you can tilt the angle, and that's important because when a vehicle is on a two-post lift, it's hardly ever exactly horizontal. It's nearly always very slightly at an angle. And when you bring the vehicle down with the battery, you want the battery and the surface that it's going to rest on to be absolutely parallel. That's why the bench wants to be adjustable. We supply our bench with some wooden beams, as you can see in the lower image here, and the reason for that is the underside of these batteries quite often have protrusions, fastener heads that protrude, and you don't want them digging into the surface of the table, and equally you don't want them getting damaged. And we sometimes find on these batteries that, believe it or not, they have an inspection port on the underside of the battery. The Hyundai Kona is a good example of that. There's an inspection port on the underside of the battery, so you don't want that flush against the base of the table. So we have our two-post lift, and we're going to lower the vehicle down onto the bench, and we've positioned the beams on the bench, and then we can undo the remaining fasteners. Just doing it at waist height, you just undo the remaining fasteners on either side, take the vehicle back out, and you can now wheel the vehicle back out. If we then want to remove the battery from the bench, we need a lifting system. So we have a lifting system that involves some beams. It's an H-beam principle and some lifting chains. And this system is rated up to 700 kilos for lifting batteries, and it will lift two types of batteries. Some batteries lift on 4 points, 4 corners. Some batteries require to be lifted on 6 points because the battery might have what we call a waist in the middle, so it's wider at the ends and it's narrower in the middle. If you lift only at the ends, there's a risk it'll collapse in, so you need to lift at 6 points. So we cover all of those options. I mentioned before about the angle of the bench. So here you can see where we've angled the bench when we've taken the battery out of the vehicle. We then need to reset it to be level, and then we're ready to do something with that battery. Now we might want to just leave the battery on the bench, or we might want to in fact move it away. When we're going to lift it off, we have to assemble the lifting rig. So one of my colleagues here is assembling the frame system, main beam. We fit some cross beams, we fit the chains, we fit some eye bolts onto the battery fastener holes, and then we're ready to lift. Okay? So very straightforward, very easy to assemble system, works with any high voltage battery. And then we're ready to lift. Once we've got everything level, we're ready to lift. We can lift the battery off the bench, and then we just wheel the bench out and the battery is left suspended. So we can now move that battery anywhere we need to take it. We might want to put it on a pallet for storage for another day. We might be going to put a new battery in. New batteries are supplied in huge big crates that require forklifts to deliver them, but you need to be able to lift the new one out the crate and put the old one back in the crate. And please don't assume, by the way, that this is the preserve of the main dealer network only. There are a number of battery electric vehicle manufacturers' dealer networks in the UK who are not equipped to do this, despite the fact that on the sales side they are selling battery electric vehicles. And they need the services of local independents who are kitted up to do this. So it might be worth, if you're thinking of going down this road, it might be worth talking to some of the local main dealers to find out if they are equipped. But a number of them are not. They rely on 1 or 2 centres dotted around the country, which is not a cost-effective way of dealing with the situation. And just finally, I often get asked if there's any legislation covering this type of subject. Unfortunately, at the moment, the answer is no. However, there are legal aspects, and all of us have a legal duty of care to our employees and to our customers, and using this type of equipment helps you to meet all of that. Various other legal aspects that should be covered, but the most important thing on that slide is training. I would certainly recommend that there are a number of training providers here today, and if you haven't considered training so far, I would strongly recommend any of them to you, and you need to be looking at level 3, level 4 training to be working on these type of vehicles. Okay? Please feel free, if you want to know more about the battery lifting process, we have it all set up on the stand behind here. You're welcome to come and see it any time during the day. Thank you very much.